Hey, it's Dr. J. Today we're going to do two sections combined, adding and subtracting at the same time. I figure might as well, kill two birds with one stone. A couple things I want to talk about adding is, try to resist using your calculator. I know every once in a while the numbers get big or you get lazy or tired and you just want to get the right answer. You're going to use your calculator. You are human after all. But one of the biggest mistakes that students make early on in their education is they rely too much on the calculator, and then you end up in college level math, and you're going to be in real bad shape if you've been spending your entire life or your entire education punching every tiny little thing into your calculator, right? And having said that, I won't use a calculator for any of these problems, and I'll show you sort of the traditional freehand way of adding and subtracting. All right, so first thing is that there are some problems that you should be using mental math for. All right, not counting on your fingers, not sitting there and going 1, 2, 3, 4, 5, or whatever. See if you can actually do it in your head. So if you have a problem, like 17 plus 29, you can do this in your head. You can do this with mental math, right? 29 is about 30, yeah? One away from being 30. And 17 is 17, so you know that this is 46. Mental math, right? Because this number is about 30. And then if you took, a number that's about 30 and then you add 17 to it, you're going to get a number that's about 47, right? Give or take. And since 29 is 1 away from 30, you're going to be 1 away from 47. You're going to be at 46. Okay. When the numbers get a little bit bigger, you can still try mental math with things like this. But typically when the numbers get larger than, say, 100, I would say that most adult humans should be able to add numbers up to at least 100 in their head. Once it gets beyond 100, you're going to need another technique. And so we typically stack them. It doesn't really matter which one you put on top, but I like to just take the smaller one and put it on the bottom. You probably learned this technique when you were very young. And then you add vertically, starting at the far right. Okay, so 2 plus 8 is 10, and then you're going to carry a 1, because you can't really put a 10 here. 9 plus 1 is 10, plus 3 is 13, and you're going to carry another 1, again, because you can't put 13 here. And then 1 plus 5 plus 2 is 8. Now, if you could have done that with mental math, that's excellent. I recommend trying it once in a while. But small numbers, use mental math. Big numbers, use the stacking technique. If you have more than one number, you're most definitely going to be stacking them. So if you have more than one number, more than a pair of numbers, sorry. If you only had one number, you wouldn't be adding. I was going to try and put 4 numbers here, but my board's not big enough to put it. You're going to stack them. And it really doesn't matter who you put on top. You're just going to put it in whatever order you like. I like some sort of symmetry and some sort of pattern. So I'm going to go ahead and put the largest on top. And if there's a medium one, I'll put that underneath. And if there's a smallest one, I'll put that on the bottom. Turns out that you'll get the same answer no matter what order you put them in. So 2 plus 3 and plus 0 is 5. 3 plus 4 is 7. 7 plus 7 is 14. 14, you got to carry the 1. 8 plus 1 is 9. Plus 2 is 11. Carry another 1. and 1 plus 5 is 6. Okay. Now, believe it or not, when you start to do algebra, these numbers are going to involve variables at some point, and you don't want to be taking out a calculator and trying to do a bunch of side calculations to get a result that you could have done much quicker by simply performing the operations. Next, we're going to talk about subtraction. Now, we're still in the chapter 1 on whole numbers, so when we do subtraction, we can only subtract smaller numbers from larger numbers. So for subtraction, you must put it in the correct order. Okay. Now you can go ahead and try this one with mental math. Go ahead and give it a guess, right? 65. Well, what would 65 minus 15 be? 15 is very close to 17. So 65 minus 15 would be 50. Yeah. But this is not 15, this is 17, so it will be 48. Okay? If you can't do that quickly with mental math, then you can stack them. With subtraction, the larger number always goes on top, and the smaller number must go on the bottom. Right? Addition is what we call commutative. It means that you can rearrange the order, and the answer will still come out to be the same. Subtraction is non-commutative. All right? Non-commutative. Non-commutative means that the order matters. Addition is commutative. Just think of the word commuting, like driving to and from work or to and from school back when we used to actually go to school. Okay, I already know the answer is 48, but let me just show you how to do it here. So you would do 5 minus 7. Well, you can't do 5 minus 7, so you have to borrow from the 6. Make this a 15. 15 minus 7 is 8. And then 5 minus 1 is 4. And notice you get the same result either way. With large numbers, I don't even bother trying the mental math. So if you want to try to take a mental math guess at this, go right ahead. But I'm not going to. I'm just going to go ahead. We have the larger number and the smaller number. The smaller number must go underneath the larger number. And then you're going to subtract vertically. All right, 2 minus 3. Well, you can't do 2 minus 3, so you're going to have to borrow from the 1. That makes that a 0. And now this is 12. Yeah, so you're technically borrowing 10. I know we call it borrowing a 1, but you're actually borrowing a 10. So now this is 12. I don't know if you can see that, but that's 12 now. So now you have 12 minus 3 is 9. Okay. Now you got 0 minus 5. Well, you can't do 0 minus 5. So you're going to borrow from the 4 and make that a 10. 10 minus 5. That's 5. Oh, a lot of borrowing in this one. You can't subtract 9 from 3. So you have a 2. Excuse me. You don't have a 2. You have a 13, because you're going to borrow 1 from the 7. Make that a 13 minus 9. 13 minus 9 is 4. And then finally, 6 minus 2 is also 4. When we put this together, add or subtract as indicated. So when you're adding or subtracting, to get a new wipey there for the board. So when you add or subtract as indicated, you must go from left to right. You must go from left to right. A very common mistake would be to come over here and try to go 76 plus 20 or something like that. Now, I'll tell you what, when we get to the chapter on negative numbers, we can be a little bit more free about how we perform these operations. But when you're talking about whole numbers are basic arithmetic. You must follow the rules from left to right. I like to just do them in pairs. So 57 minus 20 is 37. And then 37 plus 76, what would that be? 113. Again, if you have to stack them, you can stack them, but you must stack them in pairs. So you would have to stack these two first, figure out what you get. These are relatively small numbers. They're all less than 100 until I get to the final answer. And then finally, I could have stacked the 37 and the 76. Okay. How about something like this? 54 minus 12 minus 9. All right. Again, you need to go from left to right. So be careful that you don't accidentally go 12 minus 9 first. So 54 minus 12, again, these are relatively small numbers. So 54 minus 12 should be 42. And then 42 minus 9 is 33. Okay. So that was a quick, 12-minute review of all of the math that you learned before you were, 10 years old or something. And it turns out, I have this saying, the most important things you ever learned about math, you learned them before you were 10 years old. Next, we're going to talk about the way we speak mathematics. Most of the operations in mathematics are relatively straightforward. When you're translating from English to math, you have words like sum, difference. So sum would mean addition, difference would be subtraction. You also have other ways to say addition. You can say more than. That would be another way to say addition. And you could say less than. That would be another way to say subtraction. You could make a little chart of all the words that you're going to need. I'm kind of running out of room here, so I'm going to just add a row at the top here. You could also say decreased by. That would be another way to say subtraction. So I'm kind of alternating sums and the differences. And you could say increased by. We're going to be spending quite a bit of time in this semester solving word problems. And the word problems will start off very small. They'll just have one line, and then you solve it. By the end of the semester, I will have you trained to solve an entire paragraph of words, and then you come up with the equation, and you solve the equation, and you're going to be doing that all on your own. I hope I didn't skip a number here. I think I'm up to example 8, right? Let me look. Okay. So we're going to translate into an expression and then find the result. Okay, let's start off with an easy one. The sum. The sum. Well, that one's pretty obvious, right? The sum is addition. So the expression. So I'll give you credit for not only coming up with the expression, then also calculating the result. 42 plus 15 is 57. Okay. Addition is commutative, as I mentioned before. Commutative means that if you change the order, you will still be marked right. So I could say 42 plus 57, sorry, I'm stepping over my words. 42 plus 15 is 57. We typically read the equal sign as the word is. Yeah. Or you could say 15 plus 42 is 57. It's a commutative operation. Changing the order does not change the result. The difference between 116 and 39. So what is the difference between 116 and 39? Well, difference would be subtraction. Yeah, subtraction. So you have 116 minus 39. That would be your expression. And then the result is 116 minus 39. If you have to, come over here and do some scratch work. Although you could probably do this one in your head, but let's just go ahead and do it this way. So that'll be, we'll borrow a 1, or technically a 10. 16 minus 9 would be 7. And then we'll borrow another 1. So 10 minus 3 would be another 7. So the result would be 77. Probably could have done that mentally. Look, 116 minus 40 would be 78. Yeah? And so it's just 1 less than that, so it's 77. Actually, let me say that again. 116 minus 40 would be 76. I got to say that correctly. And then 1 more than that would be 77. Typically, when you do mental math with big numbers, you might be off by 1 or something. Either 1 too many or 1 too few typically is the common mistake. Now, here's a very special case. One of the problems will say something like this. Less than. All right. Less than is a very special type of subtraction where you must reverse the order. Subtraction is non-commutative. Yeah, this is non-commutative, which means that if you put it in the wrong order, you will get the wrong answer. You know, for example, in this last example, if I would have had the 39 first and then the 116 second, it would have been incorrect. All right. So you must reverse the order. You must put the 89 first and then subtract the 34. So the expression is non-commutative. If you have it in the wrong order, you'll get the wrong answer. And the result, 89 minus 34. Let's try mental math. We can do mental math. 9 minus 4 is 5. 8 minus 3 is also 5. So you get 55. If you have to stack them, stack them. All right. When the numbers are small, it's a gift. When the numbers are large, you might have to work a little harder. Okay. So you can do all of these, subtraction, addition, more than, increased by, decreased by. And I'll leave that to you to solve. This is the only one, less than is the only one, or the only translation that is reversed. All right? This is the only one. All the rest of them, you're just going to put them in whatever order the problem is given in. Next, we're going to talk about some geometry. Okay, and the word of the day, perimeter. Perimeter. Peri means outer or outside. Yeah. Think of words like peripheral. Peripheral means it's on the outside. Or you go to the dentist and they clean the outside of your teeth. That's periodontal. That's like cleaning your gums and things like that. So anything with the word peri, P-E-R-I, means outside. Meter means measure. So perimeter literally translates into English as outer measure. We are measuring the outside of a geometric shape. All right, so how about this one? We'll start with a rectangle. It's not a very good rectangle, but it's fine with me. 15 and 22. What would the perimeter be? Well, if this side is 15, then this side is also 15. And if this side is 22, well, then that means this side over here is also 22. So the perimeter would be 15 plus 22 plus 15 plus 22. If you want, you could group them together. You could put the 15s together. Might make it a little bit easier. Put the 22s together. 2 15s makes 30. You could probably have done that with mental math. And 2 22s makes 44. And so the perimeter would be 74. In chapter 1, I'm not really spending a lot of time with measurements, so I'm just going to say units. In the future, we might say inches or feet or meters, etc., etc. But I have an entire chapter on measurement coming, not soon, but not too late in the semester, where we're talking all about the different types of units. In chapter 1, I just want you to get the right answer. Okay. Eventually, I'll make a real big deal about what is it, inches, is it feet, is it miles, what is it? So that's a rectangle. I should just probably leave the instructions up here. This next shape is called a parallelogram. Yeah, it's kind of like a rectangle that fell over. Yeah. Let me see if I can make it look better on the camera. So we'll say this side is 32, this side is 50, and then the inner side here, there's an inner invisible height, and the invisible height is 46. Now, you might wonder, why are you even giving me the 46? Right? Because you don't really need it, right? You only need the outer measures. The 32, that means this side down here is also 32. 50, and then the opposite side is also 50. So this is not outer. It's not peri, it's not perimeter, it's not in the peripheral. So you can just ignore the 46 altogether. In my next lecture, I think it's 1.4, we'll talk more about what we actually will do with that value, but not today, because today we're just talking about perimeter. So I've got two 32s, can group those together, and I've got two 50s. You can either add these, or you can just multiply by 2. It's the same thing. 32 plus 32 is 64. 50 times 2 is 100, and so you get 164. All right. So you need to know what to look at, what's important, and what's not important. We're going to do a couple more shapes, and then take any questions if you have any questions. Email me or come see me on Zoom. This next shape you probably know pretty well. It's a triangle. Let me try and draw it a little bit better. The triangle also has, oh, come on, don't do this to me now. Don't do this to me now, come on. The triangle also has a height. Sometimes we draw it with a dotted line. And so the height here is not important. Come on, we're almost done. We're almost done. Don't make me stop the video. All right, hopefully it's not too blurry. Let's give it a second. Get a drink. Come on. Come back to me. So the height of the triangle here is not going to be important. The perimeter is just going to be the outer measure. Almost done. Don't do this to me, please. Come on. This camera is really picky. Come back to me. There we go. There we go. All right. So the height is not important when we're talking about perimeter. All right. We will need to know the height. It's like, imagine like a tent pole. If you're inside of a tent and there was a pole holding up the roof of the tent, that height will be important when we're talking about area. But when we're talking about perimeter, all we care about is the outer measure. How big is this all the way around? My drawing is not to scale. Sorry, not only does my camera blur out, but it also kind of stretches things out a little bit. So the perimeter is 76 plus 59 plus 42. If you want to stack these, it might be helpful. 6 plus 9 is 15. 15 plus 2 is 17. Carry the 1. 1 plus 7 is 8. 8 plus 5 is 13. 13 plus 4 is 17. So the perimeter is 177. 177. All right, so we got rectangles, we have triangles, we have parallelograms. We're not going to do circles yet. It turns out that in order to do circles, you need decimals, and in chapter 1, we don't have decimals, so no circles yet. The last thing that we'll have is called a polygon. It doesn't have to be the shape of an L, but a polygon is any shape that has more than 2 sides, because you have to have at least 3. Yeah, so strictly more than 2. 3 is the minimum, okay? And it can make any shape. So any possible shape that the sides have to all be connected, we call that a polygon. If you really want to know, this is called an irregular, what is it? 1, 2, 3, 4, 5, 6. An irregular hexagon because it has 6 sides, but well, that's neither here nor there. All right, this side is 4. This side is 10. This side is 16. I know the drawing is not to scale. Try to make it look a little bit more to scale. Okay, and this side is 3. This problem's a little bit tricky because we don't know these 2 sides. We have 2 unknown sides. 2 unknown sides. Now you could take a guess as to what it is, yeah. But man, this is really out of scale, isn't it? This should be much skinnier than that, but don't worry about that. Just go with the numbers that you're given. So you know that this is 3, yeah. So if this is 3, then that means this side down here is also 3. Yeah? I'm assuming it's, rectangular shape. It's not getting wider at the top. My camera's a little bit skewed, but it should be relatively rectangular. And then you know the total here is 10. So you got to do a little mental math. Here's your first little bit of algebra. 3 plus what would equal 10? And I think you can all just do that with mental math. That would be 7. Yeah, 3 plus 7 is equal to 10. So here's your first look at algebra. We'll get a lot more sophisticated with it as we move along. We'll introduce variables x and y and a and b and things like that. But for now, I'm just going to do it in the most elementary sense. Okay. All right, and then now you have this side is 4. Yeah. And then again, I'm assuming that this is rectangular in shape. It's not getting skinnier as we go along. So as I go over here, I would know that this is also 4. This side here would also be 4. I don't know if you can see that. Yeah, I'm ignoring the 3 now. I don't need that anymore. I've already taken care of that one. So it's just this side is 4. Okay, so now I have 4 plus what equals this total side here. The longest side is 16. And you can solve that again with mental math. 4 plus 12 is 16. So this side is 12. All right, once you've found all the outer measures, you don't need any of these inner measures anymore. So you just have 3, 12, 7, 4, 10, and 16. Now you want to ignore the inner measures. That's why I just erase them. You could also just cross them out so you don't accidentally add them in as well. All right. I think we're basically done. Let's just add these up and see what we get. So the perimeter, let's start using words here. At some point, I'll just use the letter P. Yeah. Right now, I'm just going to use the whole word perimeter. Now, be careful with this. You might want to put a pin wherever you start so that you know where to stop. So you got a pin in it there. 16 plus 3 plus 12 plus 7 plus 4 plus 10. And I don't want to do double dip on the 16, so I'm going to stop there. Let's do a mental math challenge. We started this lesson with mental math. Let's see if we can do it all with mental math. No hands, no fingers, no calculators. Let's just do it. 16 and 3, 19. Yeah? 19 and 12. 19 and 12, 31. 31 and 7, 38. 38 and 4, 42. 42 and 10, 52. All right. If necessary, stack them all up and then add them down like as if you were keeping track of your books. Bookkeeping, you know, the original art of keeping track of things. All right, I guess that was a pretty quick lesson, huh? Good thing I combined those two sections together. The next section will be another combo section tomorrow, but until then, this is Dr. Jordan. I will see you on the internet.